So in today's session, we are going to enable some of the complex scenario using queues and Azure Service Bus. So what we're going to do is we're going to write this Python app here to send some messages to these other Python apps which are listening and waiting for these messages to act on it and do something. So as you know, the Streamlit applications are very simple to write. We are not going to talk about how to build a Streamlit applications. If you want to learn about Streamlit applications, you can see playlist in this channel where we have multiple videos teaching you how to build a Streamlit application. What we're going to do in this session is that we'll have this application written in Pythons as a sender and receiver, and using Azure Service Bus Queue, we can enable some of the complex scenario which may happen in production. For example, this is a Streamlit application. This can be a UI which is telling bunch of Python apps, and now these apps can be sitting in Python or they can be Azure functions, and they will act on it. For example, they have to do some calculations, run some machine learning models and things like that. They will do all that, update the database, and then they can send back some messages to this Streamlit application, and which can then go ahead and update the dashboard. So there can be many scenarios which you can enable with this design pattern. So let's talk quickly about the queue. So the queue in Azure is a very simple queue. It is first in, first out queue. So you put the messages, and the other app which are listening, which are the receiver on the queue, can get that messages. Now these queues are very durable. So when you write a message, it's triple backed up in the cloud. So depending on how you are configuring this queue, this can go across multiple regions. So even if you're a data center blown up, you will not lose your messages, you will not lose your queue. So this is extremely durable queues are there. And then the receiver, this pulls the message out of the queue. So that's one of the drawback here. It's a polling mechanism. So whenever Python apps need to get a message, it has to poll this queue. And whenever it pulls the message, it gets the message. I will say kind of a negative, because whenever I'm polling something, I may be wasting time. But this scenario is fine when I know that every second or every minute I'm going to get some messages. And so I can go ahead and poll every minute or every 5 minutes, things like that. But this polling will not make this Streamlit application, which is showing some kind of dashboard, not very performant. It will not be very quick to show the updates because they are polling each other. So the scenario where I have to have bunch of subscribers, it's not only one, but many subscribers supposed to be activated depending on the messages. That's the place, that's the scenario where we will go and start using event grid. So in the event grid, they have a concept of topic. So imagine topic is as a publisher. This application is a publisher, and it's publishing a topic. And there can be a bunch of subscribers. They can subscribe to this topic. So this is a scenario where I want to fan out, or I want to activate different subscriber depending on my topic. That's when I will use this Azure Bus topic and subscriber model. And this topic we going to very soon going to build it in event grid. So there are many advanced features of Service Bus. One thing you can do is you can still do first in, first out by using the session manager of Service Bus. So if you want the Service Bus behaves like a queue, you can do that too. Second is you can do this topic can fan out to multiple different topics. So one scenario is this, that you can take this and you can have bunch of subscriber which are themselves topic, right? So you can fan out like this. You can fan out a message to different subscriber. This is kind of auto routing the messages, because when I am defining the subscriber, I can say what messages I'm interested in. So when a topic sends a message, depending on my subscription configuration, I can receive only those messages. We'll talk more about it when we will build this subscriber, or we will see it in the code also. So that's one thing you can do, that you can auto route messages here. Second thing is, they have a concept of dead lettering. Dead lettering means when one of the subscriber is dead, suppose he is not responding or is not running, in that scenario, the messages can go in the dead letter and then they can just wait there. And depending on your production scenario, it often happens you have to dig out messages from the dead lettering sometime. But it's very rare. Of course, it's addressing the scenario which is rare, that your subscriber is dead for good amount of time. So the messages can go there. The other feature you have is you can have a scheduled delivery. You can send this message in night at say 9 p.m. and tell them that deliver this message at 9 a.m. next day. So say it's sending a press release which has to go only at 9 a.m. But you can send a message saying that deliver this message at 9 a.m. Of course, we talked about this auto forwarding. Then there's a auto filtering is there too. By that, we will see more when we will build this subscriber, that you can define the subscriber is only interested in certain kind of messages. So you can do filtering and take action on it. Next feature is there, which is called auto delete on idle. So it can automatically delete also messages if they are just there and nobody is picking them up. So in effect, you can put the TTL, time to live, on the messages. So they can automatically delete. You don't have to do another extra work in case where the subscriber are not there. The messages will automatically delete. Of course, like everything else in Azure, they do have a geo disaster recovery. You can have this disaster recovery. So when Azure region or data center experience downtime, geo disaster recovery enables data processing to continue operating in different region or data center. It doesn't matter one or two data center having a problem. Your business will not stop. So now let's go and see how we can build a topic and the subscriber. So to build our first topic, let's go and create a resource. Here, search for event grid. And first thing is event grid topic. There's nothing in the drop down. Don't know why it is a drop down. Maybe just making it future proof. Here's your subscription. You choose your resource group, give any name, and then choose the region. Next is networking. Here I'm going to leave it as public access. So don't worry that public access does not mean that anybody can access this event grid. They do need a key to access it. So it is public access. By that I mean you can connect to it if you have the key. If you can turn it into private access, then you need to create the endpoint to allow a private connection to this resource. So all those configuration is there. This is advanced scenario. You can do that. But for now, for our session, we'll just keep it as a public access. And you can see that you can set up the firewall also around it. Event grid schema. Now, there are 2 or 3 different kind of schemas are there. And if you want to see the detail, let's go and check them. So here you can see the event schema. It talks about there's a topic, subject, ID, event type. This event type, remember this is an important thing, because this event type enables the filtering on the service bus. And then of course you have the data. This can be a plain vanilla JSON data. It can be anything, whatever you want. And of course data versioning and metadata versioning is there. And these things come in picture when you are working in production for some time and you have different versions and different applications behave differently depending on the version. So this is a very simple event schema. So this is cloud event schema. You can come here and read more about it. And for our scenario, we'll just keep it as event grid schema. And we are turning it off, enable system assigned identity, because then you have to have the identity defined. We are not doing that. Local authentication, yeah, we need SS keys to connect it, so leave it enabled. Tag is not necessarily, but it's a good idea to have tags defined for your resources in production. But I'll skip it, and then you go ahead and create this event topic. So when I click create, it's gonna go and create this topic. So once the topic is created, second thing we have to do is we have to go and create the subscriber. So let's go back here and go to our event, which we just created by clicking create. And here's the way you create event subscriber. So event subscription, here you give the name for the subscriber. Remember, we chose the event grid schema, so keep the schema same as the topic. Subscriber should be in the same schema. So we don't have to worry about this topic detail because we just have one topic. Otherwise, you can pick a topic resource for which event should be pushed to your destination, because we are defining the subscriber here. But I'm having just the one topic, so we'll leave it as is. And this is the event type. Remember the event type, we talked about it. This is how you can filter to event type. So you can say this subscriber will deal only with these kind of events. So this is important, and we will see it again when we will write the code that event type can be defined in your JSON because it's part of the grid schema. Now endpoint type, there's a bunch of different endpoint types you can do. Of course, Azure functions, as everybody knows, these are the Azure functions. They are running as a function in serverless environment. They can be the subscriber. Webhooks, similar thing. They are again web services which are running somewhere. They can be defined. Now there's a storage queue and there's a service bus queue. What is the difference between two? Storage queue generally deals with huge amount of queues when you are dealing with millions and millions of events at a time. Or your storage queue need to be above, I don't remember, but it's like 80 or 70, 90 gigabyte size. That's the time you will use storage queue. This is the queue put on top of storage. So a scenario where you are having a production and you have a bunch of applications and they are logging and sending continuously a lot of events. That's the time maybe you will put it on storage queue. So remember, the storage queue, what is happening is this is what we are defining here, the subscribers. So the option there can be that I can choose a storage queue. We can take a look at that. And then you have event hub, hybrid connection. Hybrid connections are the connections which are inside your enterprise, but they are not accessible from external. They don't have any public endpoint. So these are the hybrid connections. So if you'll choose this, you have to be in your own network. And of course, then you have Service Bus Queue and the Service Bus Topic. So again, when we say Service Bus Queue and Topic, so you see you can chain the topics after topic. The chaining means this scenario where we have this topic and then it sends to another topic. So that's where we will use this Service Bus Topic. And then, so this can be used for auto routing from one topic. Messages can fan out to 3 different topics and then they will be connected to another queues. And this last one is bus queue. This is what we're going to see also. So it's a service bus queue, but it is defined as one of the subscriber. So the messages which will come out of the topic will fall in this queue. And we will see how you can read and write these queues. So let's check. Oh, and the partner destination, I don't know exactly what does it mean. I am guessing partner destination is that if you have partner apps like SAP or some ADP app, which is event grid compliant or understand the pub sub model, you can choose those partner destination apps. So let's look at first storage queue, and then we will look at the service bus queue. So storage queue, when we choose this, manage identity types, I can leave it none, but here you have to go and configure it, select an endpoint. So when you click here, you choose your storage account. Generally, you have to have storage account provision before you come here. And then you can choose a queue on top of it, or you can create a new queue, which will be created on top of this storage queue. So let's go and quickly take a look at the storage queue first. So if I come to my event, this is my storage queue. So click this one, and here's my storage queue. Click on this, and here's the queue. Okay, queue here. If I refresh, I see these are the events in the storage queue. They are kept. So let's clear this queue. Now let's go to our code and write a Python application. This application, which will write the topics, which will write these messages to the service bus. So let's look at that. But before we go there, we need to get two things. Before you write the code, we need two things. One is we have to go to this event topic, get the access key. But look here, the topic endpoint, copy the endpoint and get the access key. Once you get the access key, then let's go at the code and look at how we can write this code. So we are here, write event. So now we are in Python Word, and you can define this Azure event key and endpoint, which we just copied from the website. Here you can see that you have to pip install Azure Core and Azure Event Grid. These are the two things you have to install. So say pip install azure.core, azure.eventgrid. Now let's look at the code. What's happening here? I am creating data. This is very simple. I'm just creating a JSON object. It just have three attributes: producer, subscriber, and timestamp. And then I create the event. So when I create the event in data, I put the data, and then the subject, I put any subject I want. And look here, event type. I write this event type here. Remember again, this event type is used for filtering the messages to different subscriber. And then of course you can give the data version, and you can give the data metadata version also. Now, this is how I am sending the event. I create the data, which we've seen. Create data is create a JSON blob, then create the event. So I create the event, pass the data to it, and then send the event. Sending event is very easy in Python, just 3 lines of code. Of course, when everything is laid out, everything seems very easy and simple. Create the credential, create the endpoint, create the client using the endpoint, and then send the event. So if I would want to see this event, let's see, and this queue, and there's nothing here. I refresh, there's nothing. Now let's see if we will send this from here. So this goes in a loop and just keeps sending the messages. So whenever it sends the message, it just puts a dot here, print dot. And as you can see, it's sending 3 messages so far. If I refresh, I see all these messages here. So this is as simple as this, that you send event, create the client, give the credential, and send the message. Very, very bad code. Never write something like this while true and remain in the loop. There always must be a reason to break the loop. So anyway, this is for just to show how to send the messages. Now let's figure it out how to read messages. But before we read the messages, let's see how I can create another subscriber on the queue. So here, as you can see, we already checked the storage queue. We send the messages to it. Now let's look at the service bus queue. So how you will create the service bus queue? Again, you go here, event subscription, because we are defining a subscriber, and this subscriber name can be there. Again, if you want to filter it out. Otherwise, you come here and choose the service bus queue here. And then you say, before I say create, I have to go and select an endpoint. Now, first time when you will come here, you will see nothing in the service bus namespace and the service bus queue. So these two things, the service bus namespace and the queue, we have to go and create before we come here. So let's open another tab and create the service bus in the Azure portal. Now I'm here, I'm creating a resource and I'll call it service bus. Enter service bus. Click here, create this. So you can see there's a plan which is just one drop down and say create. When you're creating, you give your resource name, your namespace, whatever namespace you want to give, and then here's the pricing tier. As you can see, it's very cheap. It's like 5 cents for 1,000,000 operations. You can send million of messages for 5 cents. So you can choose basic and then do the networking. Again, public access and private. Public access is fine. Don't worry, this public does not mean anybody from public can access it. They need to have the keys. Then you go do the tags. I'll skip it. Don't skip it in the production, and then review and create. So once I click create, it will create the namespace. Again, I already have it, so I don't have to create, but this is how you create a service bus namespace. So I click here in my service bus namespace, and now I have to come and create the queue in this service bus namespace. Basically, you can have bunch of queues here, multiple queues. So it's very simple. When I go and give the queue name and the max queue size, I believe this number will change depending on what pricing you have chosen. This may be the most basic one, 5 GB, but you can go much higher depending on your service bus namespace pricing you choose there. And again, you can see here it's enable dead lettering or message expiration. So you can click that if you want. And enable partitioning. This all partitioning and things comes in picture when you are dealing with millions and millions of messages and you want to have this partitioning scheme happening. See, partitioning a queue across multiple message broker and message stores. So for performance and all, you need to do partitioning, but we don't worry about it now, and we just go and create one queue. So once this queue is created, we will leave it here as is. We'll come back to it. Now I can go and complete my service bus queue creation. So here, look, this is what we left. We came back here, choose the service bus namespace, and then the queue. If I have created a bunch of queues, I would have seen this many queues. So I choose one of them and I confirm the selection. So quick recap, what all we have done so far. We created an event grid, a topic, and then we created a subscriber. First subscriber was the storage. Second subscriber was a service bus queue. And for service bus queue, I have to go and create a namespace service bus. And then inside the namespace, I create this queue. Now, to read the message from this queue, I have to have the access to this queue. And why it is I'm reading from here because as you can see, this Streamlet is writing a topic and I have two subscribers who's going to read. Let's delete this guy. So these are the two subscribers which are reading. So one of the subscriber is defined as a service bus queue. And to use that, I have to come and get the shared access policy. Click on the shared access policy and add. And then you can choose whatever you want actions to happen here. Listen, I'll click on listen and write a policy name and then just say create. Once I create that policy, which is here, if I click this policy, you can see it's showing me primary keys and connection string. And this is the connection string you need to read this queue. So copy this connection string and get this name of the service bus queue. The name is this. Here it is. The namespace is this, and the name of the queue also is this. Service bus queue. This is the name of the queue. So these are the two things you need. You need the connection string and you need the name of the queue. Now, how this queue gets the messages? That's happened because I have defined as one of the subscriber and connected. You see here, when I come here, I define this service bus queue and choose all this and confirm my selection. This is how the topics will be kept in the queue by this configuration. So now let's go and look back at our code. This is read event code. It is much simpler. Now here you go and get the install Azure.Service Bus. So pip install Azure Service Bus. And you see what's happening. We are creating a client. Before we create the client, look what we did. We need a connection string and the queue name. So these are the two things we need. Put it in our configuration here. Service bus connection string and queue name. Read it and make the client. And then you create a receiver. And now this receiver is listening continuously on this queue, and whenever any data comes, it just reads it. So if I go and run this event.py, it's reading the events which we have sent before. So now what we can do, we can run two apps which are running this reader and writer. Let's do that. So here are the two applications. One is the writer, one is the reader. So let's kick in the writer, and here is the reader. So this is it. We wrote a writer and a reader, and we enable our this scenario. Here's the writer, here's the reader, the subscriber. So we enable the scenario. I hope this is helpful, and let me know if you would like to see something different. In this session, we talked about Azure Service Bus. You can do the same thing with Amazon also, with AWS. If you want to see in AWS, let me know. But the fundamentals, the concept will remain same. Only the code which is reading and writing from Python will change and the libraries will change. Not much things will change.